Hey everybody, welcome to the Neo4j online meetup. This is episode 24, I think it is. And this week we've got Jonathan Freeman with us. So for those of you who haven't joined us before, my name's Mark. I work in the developer relations team in London for Neo4j. We'll just do a little bit of housekeeping before we start. So Jonathan's got some slides with code in. So in order that you can see that clearly, you'll want to set the quality of your recording to at least 720p or above, and you can do that in the bottom right-hand corner of your YouTube video. If you have any questions, you can ask them. So I'm watching the YouTube chat, and Jonathan's watching the Neo4j online meetup Slack group in the Neo4j user Slack, so you can ask questions in either of those places. Of course, if you like the video, don't forget to like it so that Jonathan will be happy. And I guess with that, I'll let Jonathan introduce himself. So maybe just to quickly say, introduce yourself. What do you do? How did you get involved with Neo?
Yeah, sure. So hey everybody, I'm Jonathan. I'm a software developer. Right now I'm consulting with a company called Dietary. And sort of during my day-to-day business, I'm working everywhere from infrastructure automation, doing like container orchestration stuff with Kubernetes and GCOS, all the way through the application stack, data stack, up to the front end with like React Native and data public development. So it's kind of all over the place. I got interested in Neo4j probably about 5 years ago, and have been sort of playing around with it and using it for projects and applications ever since. And I'll sort of, in the course of the presentation today, I'll talk about some of the things I loved about it, and why I keep turning to it as a tool.
Cool. And so the reason we've got Jonathan with us today is because he tweeted about a talk that he did. It was in July sometime about some Instacart analysis, and I thought it sounded quite interesting. So that's what Jonathan is going to talk about. I'm going to hand over control to you. Any questions, as I say, YouTube chat or Slack, and I will forward any questions from the YouTube to Jonathan.
Cool. So I'll go ahead and share my screen.
Cool. Yeah, I can see it. I think we're ready to go.
In the presentation mode. All right, so this is 400 bags of grocery receipts in Neo4j. I figured that, well, I'll get into that in a second. So early May, Instacart open sourced 3 million orders. It was super heavily anonymized data, and they open sourced it as a part of a Kaggle data science challenge, where they were basically just trying to see if people could figure out what Instacart users were likely to order again based on what they had ordered in the past. And I saw this data set, and my coworker Sebastian shared it with the group, and I started thinking about some ways to use it, and I immediately thought to use Neo4j. And I started feeling like kind of a private investigator in a sense, because you're dealing with a kind of data that people don't generally think of as like identifying information, but I think you can probably learn, I figured you could probably learn quite a bit of information based on somebody's patterns of behavior around their eating and ordering food. Started to wonder about things like, could you identify like vegetarians or vegans from the data set based on what they ordered? Or if you had somebody who ate meat, could you identify like how much of a carnivore they were? Can you figure out if somebody's ordering for themselves or a couple or a family or an office? And so I started thinking about this, and I kind of thought sort of private investigator style, but really it's a lot closer to this. You're looking through somebody's trash. You're looking through these receipts that people normally just throw away. This is the digital version of course, so you don't actually have to get dirty, but it's a little bit closer to what we're actually doing. So during this talk, we're going to talk a little bit about the data and going about data modeling in Neo4j, the mechanics of getting that data into Neo4j to play around with it, going through the actual dumpster diving, which is where we'll look at the data and try and see if we can figure some stuff out based on what's there. And if we get to it at the end, look at maybe some of the production concerns. So if you wanted to take this from sort of a local analysis tool to something you're actually running in production, what you would want to do in terms of like machine sizing and importing data and whatnot. So that's what we'll talk about. I already mentioned all this information, except for the fact that in my free time I like cooking and playing music. So go ahead and continue. So data and data modeling. So real quick, the data set that they released was 3 million orders. And it's super, super anonymized. It turned out to be between, I think, 4 and 100 orders per user for something like 206,000 users. And this is sort of the schema of what the CSV looks like. So you can see on the left, we've got an order. There's this join table, order products, so you can tell which products are contained in which orders. And then you have some information about where those products are in the store. So the products are on an aisle and they're in a department. We've got that information by aisle name and department name. Some of the interesting things you'll see here on the left is, well, first of all, there's an order ID. That's not very interesting. There's a user ID. There's not a specific user table. All of this data is so heavily anonymized, they didn't want to add any user information, so they just gave you the ID to be able to identify the user, but there's no other information. So that's one interesting thing to note. We have the order number. So this is like the first order that this user made, the second order, the third order. And we don't have much temporal information. We don't have timestamps or anything like that on when these orders happened. But we do have the day of the week that the order happened, the hour of the day that the order happened, and then for any order past the first one, how long it's been in days since the last order. So for the order products join table, there's a little bit of extra information than just pointing between orders and products. And that is the order that this product was added to the cart. So we'll be able to tell, like, if this is the first thing the user added to the cart, if this is the second thing they added to the cart. And then also for orders past the first, there's a little bit of information about whether the product was reordered. And this is something we can sort of derive, but they're giving it to us for free ahead of time. So that's pretty nice. So that's a CSV model. And I think one of the first things we want to do is take a look at the graph model and see how that differs. And so one thing that's fairly typical when you're modeling, going from like this relational style model to a graph model, is join tables kind of go away. And so in the middle of this image down on the bottom, you see this relationship. It's in order. So the product is in an order. And in order actually corresponds to this order products join table. We don't need like a discrete node for this. We'll just use a relationship and then take the add to cart order and the reordered information and then just stick it on the relationship. And then it's much easier to get from a product to an order. Order is very similar to the CSV model. It's got all the properties of that attached to it. Product, aisle, and department. Those are pretty straightforward one-to-one mapping. So product is in a department, it's on an aisle. There's not much information on either of those aisle or department nodes anyways. So there's not much we have to do there. One of the things that I did do is break user out into its own node. And one of the reasons I did this is because it feels important in the structure to actually have a user be its own thing, even though we have very little information about what a user, other than the ID. But structurally in the graph, this is super important because then we can traverse from order to users to all of their other orders in a really clean way without having to do property lookups or anything like that. So that's the graph model I chose. And then I needed to actually get it into Neo4j. And there are a bunch of different ways of doing this. And the way I chose to do it, I'm sort of playing around with this locally, is using the import, the load CSV syntax. And I'm using this with headers. So the syntax is really straightforward. You have to make sure that this file is available to the database. So you might have to put it in a particular path that Neo4j can access. But once you do that, in Cypher, and I'm actually all of the queries that you see and all of the visualizations are just done in the Neo4j browser, which ships with Neo4j. So when you load up Neo4j and you have it bind to localhost, you just, in your web browser, go to localhost:7474, and this will load up, and you'll be able to query the database. And so all of these screenshots with Cypher, or almost all of them, are from that, and the results are also from that. So all I'm doing is pulling each CSV line out, and I'm saying as line, and so at the end of line 1, this as line syntax means that we're just going to take each row of the CSV and then do something with it. And on line 2, this is the thing that we're doing. I'm going to create a node with the label department. I'm going to pass through the ID and the name properties. And that's pretty much all it takes to load data from a CSV into Neo4j. You can also load remote. So if you have like remote files, so if you have this CSV in like some public place, you can pass a URL in here, but you need to whitelist those URLs beforehand. So it's easier to do it locally. So let's see, it works with relationships too. So I've loaded departments. It's basically the same query for aisles, and now I want to load products. And products is, there's only 21 departments, 134 aisles. That's pretty small data so far. Products, there's about 50,000 of them. There are a couple differences in this query. The first difference is that in line 1, we're saying using periodic commit, which is just going to make it a little bit easier in terms of memory usage on Neo4j. We're not trying to commit all 50,000 in one transaction. We're going to actually split it up into several transactions where the sort of batch size is 10,000. And then I'm doing a little bit more complicated stuff once I pull each CSV line out. The first thing I'm doing is actually matching an aisle and a department. Products in the product table have direct IDs of the aisle and the department that they should be associated with. And so you can see that I'm matching by ID the aisle ID and the department ID that are present on the products line. And that's just so that on line 4, when I create the product, I can also create relationships to the aisle and the department, which already exist. And so it's a pretty nice way of loading data in, and you can do some sort of post-processing and restructuring of the data. And I found it to be pretty versatile. And that leaves us with something that looks like this. So the green node on the left is our user. It's pointed to a red node, which is an order. And then all of the products are sort of encircling that order. That's the relationship type between the product and the order is in order. But in the Neo4j browser, you can replace the default labeling, which is relationship type, with a property. And so in this case, I replaced it with a property of the add to cart order. So we can see just by looking at this that soda was the first thing added to the cart, organic string cheese was the second thing, and so on. Now this doesn't take a look at the departments or the aisles, so I just threw in an extra slide to show that here's pierogi and onion. It's some frozen meal. It's in the frozen department, and it's on the frozen meals aisle. And so that's the data set, the data model. It's pretty simple, and it kind of maps pretty closely to the CSV that we saw, but with a few differences in removal of that join table. So before we go any further, I'm just going to look down and check the Slack to see if there's any questions yet. Nope. And this is just a reminder, if anybody's watching and they have any questions, feel free to drop it in Slack or drop it in the Hangouts chat window. Try and get to it in line. But there'll also be room for questions at the end, I believe. So, okay, so let's take a look at all the products. I wrote a quick Cypher query here that just figures out all the products and returns the amount of times that they've been ordered. So we've got, this is kind of just the most popular products. So we've got bananas, bag of organic bananas. Those probably are kind of the same thing. I mean, they're distinct products, but conceptually they're very similar. So those should be coalesced into just one, but you get the idea. These are the popular things: avocados, strawberries. that's just to sort of give you an idea of what sort of products and accounts that we have here.
I wonder what the difference between those avocados is. They look, the Hass avocado.
Yeah, so we've got, so it's kind of interesting. We've got, and this is not on this slide, but we've got organic Hass avocado. And then there's another product that's just Hass avocado, which is also fairly popular. And then we have organic avocado here. And then we just have avocado. So the distinctions are important from a product standpoint, but from a conceptual standpoint, they might be more or less important. Okay, let's have some fun. So now we've got all the data and we've got sort of an idea of how many times people are ordering these things. Let's see what we can find. So the first thing I wanted to do is figure out dietary resurgence. Like, can you figure out vegetarians or vegans or people who are gluten-free? And the data is really low fidelity. I mean, essentially when it comes to figuring out if a product has meat in it, we only have 3 clues. We've got the department that the product is on, the aisle that the product is on, department the product is in, the aisle that the product is on, and the name. So we can do like some string matching, but it's like we don't have that much information about it. So I decided to choose like a pretty coarse grain search first. So let's just get all the departments and see what we have. There's one down here, it's kind of small text, but there's one down here at the end that says meat and seafood, or meat space seafood. Seems like probably a vegetarian would not order an item in that department. So okay, we can create a very like kind of a laughable definition of a vegetarian. That's if somebody has never ordered a product on meat, the meat and seafood department, then they're a vegetarian. And by that definition, if we find somebody who meets that definition and pull up the products that they've ordered and sort of aggregate on the number of times, we can see that we've failed pretty miserably because the third item is original beef jerky. And that's definitely something that a vegetarian wouldn't buy. So, you know, it's possible that this actually is a vegetarian that loves their dog. Their dog is like really picky about what they eat for treats or something like that. But it's more likely that our definition just sucks. So let's look at original beef jerky to see what that actually is, and see where it is in the store. And this is a query that figures out what aisle and department are associated with this product, and it's not super helpful. It's on the or it's in the snacks department, and it's on the popcorn and jerky aisle. And that's a little bit tricky because it's not a specifically meat-centric aisle, but it's half meats. So the popcorn side of this aisle is probably all vegetarian, and the jerky side of this aisle is probably all non-vegetarian. So the aisle, this doesn't really help, but we can gain something by looking at other aisles to see, you know, what if there are any patterns. And so this is just pulls back all the names of the aisles, and like some of these coming back say packaged meat, and that seems like promising. Maybe we can just do some string matching on the name of the aisle. But we also have things like marinades, meat preparation. So if we just search for aisles that contain meat or contain seafood, for example, we get some false positives. So we've got tofu meat alternatives and marinades meat preparation. And this, like, I started going in a kind of whack-a-mole mode because you have this general query that brings back mostly good data, and then you have a couple things that you have to make exceptions for. So I want to strip out marinades meat preparation because most of those items are vegetarian. I want to strip out tofu meat alternatives because those are explicitly vegetarian. And then I also want to add that popcorn and jerky aisle because after pulling up that first department-based vegetarian, I felt like I had a little egg on my face. It's like, I'm saying this person is a vegetarian, but they've ordered jerky a bunch of times. So I would rather say that somebody who's ordered popcorn is non-vegetarian, even if they are vegetarian. I guess it's like I would rather a false negative than a false positive. So I started playing whack-a-mole, and here's a query that gives me all the aisles that I want to avoid. So the new definition of a vegetarian by this like really coarse-grained logic is anybody who's never purchased anything on these aisles. And so based on that, we can figure out what vegetarians buy. So I took a subset of, I think, 1,000 or 10,000 users from the data set and ran them through this definition of what a vegetarian is. And all the users that met this requirement, I sort of aggregated on the number of times they've purchased products, just so we can sort of gut check again. This is essentially the same query I did before, but just with a group of users instead of one. And it looks better. We've got bag of bananas again, so these are popular items. Baby spinach, strawberries, we've got some dairy products, fruits, vegetables, soda. Like, so far, so good. This looks like a way better definition. And it makes sense because it's a little bit more fine-grained. It's not a perfect definition by any means. And if you scroll down a little bit more, you'll see frozen pepperoni pizza, which is definitely not vegetarian. So it's not a magic bullet, but it's way better than where we were at. And for the fidelity of the data that we have, it's actually pretty good. So let's see what we can do with this. Here's a query that figures out how many vegetarians there are in the data set. So in the last page, the last result you saw, I was just taking a subset of 10,000 users and then figuring out which ones are vegetarian. With this one, I just blew it up and across the whole graph figured out how many vegetarians there are. And there are about 52,000, which is actually a little bit more than, or I should say it's close to a quarter of the data set, because there's only about 206,000 users in this data set. So that's kind of interesting. That's a quarter of the data. The Instacart team, when they released this data, acknowledged that this is not a representative subset of users. So we can't extrapolate and say that, oh, well, a quarter of the Instacart population in general is vegetarian, but it's at least something interesting in this subset of the data set. Another thing that's interesting is how long it took. So if you look at the bottom, it says started streaming 1 records after all of these milliseconds, which is like 4.5 minutes. And that's kind of rough. It's not super rough considering we're essentially doing an entire graph scan. So we're going across 3.6 million nodes. There's a ton of relationships, and we're doing complex pattern matching on subgraphs along the way. So it's not awful, but we definitely don't want to do this within like the course of querying vegetarians as like a first step. So we evolved the model. This is the full query that I used to get that count. And you can see that I've got this, the kind of the first 8 lines are just to get those the aisle names that we don't want to match. And then the rest of it is figuring out people who've never ordered on these aisles, and then line 12 is return count. Well, all I need to do is change line 12 to set you vegetarian. So we're adding a label onto the user saying that they're vegetarian. And that's the only difference in the query. So it's a very simple change to make. And then when we can just match on you with the label vegetarian, and we get the same number in a millisecond. It's probably less than a millisecond, but it's close. So that's one of the reasons that I like analyzing data in Neo4j is that, this is a very small change, but as a result of one query, we're able to evolve the model as we recognize that we need some more information, or we need to make adjustments. And it's trivial to do so. So let's see if we can take this a step further and see if we can figure out vegans. Now, take this with a big grain of salt, and everything from now on, I've got the quotes here, quote, vegan. It's kind of a joke to define these things. If a vegetarian can be defined by somebody who eats pepperoni pizza, we really have no hope at finding vegans, but we can try anyways. And the way I tried is in that list of aisles, I just added a restriction that they could never buy any product off of any aisle in the dairy or eggs department. So it's the same logic. We're just adding aisles to this like sort of blacklisted aisles. And the results we get back are seem pretty accurate at first. We're getting a lot of the same items that the vegetarians had, except minus all the dairy products. So before we had Greek yogurt, we had 2% milk, and none of those are present. If you look down at the bottom, we've got crunchy oats and honey granola bars, and vegans don't eat honey. So this is, like, again, not a great query, but we're getting closer. We can also look to see how many vegans there are in the data set, and the number drops, which is what we sort of expect. It's a slightly less common than vegetarians. And so we've got only 9,000 users in the data set. Again, though, since we're doing this complex sort of pattern matching and structural matching across the whole graph, it takes about the same time. It takes about 4.5 minutes. So we're going to do the same thing that we did with vegetarians with vegans and add a label. And now we can start seeing if we can find vegans like me. We can start easily filtering the users by their dietary restrictions, and then without having to do a 4.5-minute query ahead of time. And so this is a query that finds a particular vegan. So we'll say that I am vegan with ID 92, that's Jonathan. We're looking for sort of any product that I ordered, and then we're looking for somebody else, some other user who's also vegan, who ordered that same product. And then we're just going to count the number of times we've overlapped and order descending by that. And the results we get back are kind of promising. We've got 190 overlaps, and then it drops off 155, 131. And so that seems like a pretty solid match. Like this other user, 1962224, might have some dietary preferences similar to mine. And so the next step I took was actually to visualize, using the Neo4j browser, pull back a graph of all the things that I've ordered and all the things that this other user has ordered, and so we can see the intersection. And immediately I realized there was a problem. And this is one of the reasons that, this is another reason that I think Neo4j is a great data exploration tool, is because you get this number, 190, and it seems really promising, but then when you look at it, immediately I knew, like, this is not a good definition of similarity, because there's really only 2 products in common. But this user so I'm 92 is on the left here, and the user on the right has just ordered one of those products a ton of times. So this user on the right might be ordering for an office. They've got a regularly scheduled order happening. It's not actually what I want. And so this is not a problem with the data model. This is actually a problem with my query. Like, I messed the query up. And what I was doing is when I was counting here on line 3, it's count P products as overlap. And the problem with that is that it's going to count that overlap for every possible combination of, like, order, product, order. So if you're following on the left, we've got like a red node, and then it goes to one of these sort of pinkish nodes in the middle, like raspberries at the bottom. And then it goes off to the right to a bunch of different orders, and each one of those is going to get counted. And that's not really what I want. What I really want is, like, the distinct number of products. And so that's the only thing I have to change about this query, is on line 3. Instead of doing count P, I'm doing count distinct P. And then the results go down quite a bit. But I think this is probably a little bit closer to what I want. So now we have 6, 6, 5. So let's take a look at this first user who matches and do the same thing that we did before. And that graph looks like what I was expecting. This is something that I'm, like, kind of excited about, because then we have the query that I wanted to write, I didn't write correctly the first time. And now I've sort of got this match a little bit closer, and it's very easily to tell visually and validate visually. So we have 2 users who are ordering the same thing, or a lot of the same things. They're getting delivered, and they're eating them at home alone. 2 users who are alone at home, ordering all the same things, and then eating them alone. And that kind of sucks. There seems like there should be a service for that, which is why I'm very excited to present Instadate. Instadate is a revolution in online dating, and it aims to solve the 2 huge problems that are rife in existing online dating solutions. One of which is that we're matched based on who we say we are. Like, there's a lot of things that we will say in online dating profiles, you know, like it's not necessarily outright lying. Sometimes it is. Sometimes it's just optimistic, you know? Like on a good week, I go to the climbing gym 3 times a week. I don't put in my profile that I've never had a good week, but you know, we get sometimes a little optimistic about these things. Sometimes people just lie. So that's one of the big problems with online dating. Another big problem with online dating is that we're matched based on what we say we want. And we are really good at saying what we want, and we are really bad at actually knowing what we want. And there have been studies that have shown this, that, you know, people walk in and they're asked, what do you want out of, like, there's a famous one with ragu, it's like pasta sauce. What do you want out of pasta sauce? And then they tell whoever's facilitating the study what they want out of a pasta sauce. Then they're presented with 10 pasta sauces, and then almost invariably they choose one that doesn't fit the description of what they said that they wanted, even though there was a pasta sauce presented to them that did fit the description. So we really just don't know what we want, and so that's kind of a problem. So why not base matchmaking on actual behavior? This is not stuff that I'm saying I'm optimistic about or I think I want. This is like, this is the food that I'm buying. This is what I'm eating. There's no like fudging the numbers here. And why not base a matchmaking service on food? I mean, food is integral to our daily life. We do business over food. We celebrate achievements over food. We create relationships over food. I mean, like, hey, you want to go grab a drink? How about a romantic dinner for 2? Or maybe a quick bite before going hiking or something. There's all sorts of different ways to enjoy food as a community. So I mean, like, once we have this information, you can then think about things like, well, do you want to be a little bit healthier? Well, we can matchmake you with somebody who's a little bit healthier based on their food habits. Or maybe you just want to have company for your late night junk food binge. Like, we've got you covered. Like, no matter what your preference is, we're good. Instadate. Hungry for love? So this doesn't actually exist, but it could. And I think that if we think about new data sets and the data sets that you experience on a daily basis at work, and you sort of play around with them a little bit more, you might be able to realize interesting use cases in which you can actually apply things like Neo4j to in order to do matchmaking services like this. When I was looking around for a particular user to matchmake, this user 92, I was just kind of scrolling through users and seeing what their order graphs looked like. And it was really interesting. This is one that came up. One of the things that I've been thinking about is, can you figure out how adventurous the user is based on what they've ordered? Like, are they ordering the same thing every time? Or are they trying new things every time? Is that even a good definition of adventurous? Maybe it's actually they're picky and they can't find something that they like, So when I saw this graph, I thought, oh, this maybe is like a relatively adventurous person. They've only ordered one thing twice, which is the enchilada, which is probably worth ordering again. And then they've just ordered a bunch of different unique things. And then I looked a little closer, and there's a little cluster on the bottom right, order 5, that's guacamole, yellow corn tortillas, and you can't see it, the whole thing here, but it's roasted pine nut hummus. It's like, hey, that order was for a party. They're catering. Maybe they, are at their own house, but maybe they just had the order delivered somewhere else. And then I looked at some of the other orders, 2 and 4, and I zoom in on there. We've got original orange juice and extra dry cava, which is like champagne, but from Spain. So somebody's having mimosas on order 4. And then the other order is clear cups and private selection Pinot Noir. So I started thinking, like, oh, well, can you find party animals? I mean, it sounds like this is for a party. Somebody is like having a little party. They're having brunch, or they're having drinks with coworkers, and they're having it at their house, and they want to order some wine and cups. And I continued scrolling through, and then I found this user who's just ordered red plastic cups a bunch of times, and then one time also ordered orange juice. And I'm pretty sure the orange juice wasn't just like consumed by itself. Like, to me, that's definitely a mixer. So let's see, like, can we find party animals? It seems like plastic cups is a thing. So if you order plastic cups, what else do you order? Well, in this case, soda. Oh, that's not, I mean, that's a kind of party. Then we have clementines, organic bag of bananas, again, that thing again. 0-calorie cola, which is another kind of soda. Apples, trail mix. Okay, that's not
avocados as well, don't forget those.
Oh, avocados, of course, lots of avocados. You know, and these are good results for sure. Not exactly what I was going for. So I refined the search to be cups and alcohol. So if you buy cups and then you buy something else that's an alcoholic beverage, what do you buy? And it looks like, you know, the most time, you know, most occurrences of people buying Sauvignon Blanc. So they're buying a white wine and they're buying some India Pale Ale and they're buying beer. One of the things that I noticed when I started going through this part of the exploration was that there's some really generic product names. Like beer is not a product name you'll ever find in the store. And this is one of the things that Instacart addresses, because they were talking about how they had to heavily anonymize this data, and as a result, there's certain products that are only available regionally, and if they had given those product names, you could then start to derive information about where a particular user is in the country. And so they had to take these sort of regional product names and sort of squish them up into like a way more generic thing. Did you have something, Mark?
Yeah, so I was going to say, like on the previous slide, effectively a lot of the products showing at the top are like the equivalent of you know, when you're doing your recommendations and there's a product that everybody buys, or there's a person that everybody follows, or there's a tag that everything has. I wonder if you could explain a bit your experience dealing with those very popular items that don't really give you any information.
Yes, and actually, in a few slides, I'm going to get to one particular strategy for dealing with that. One that I haven't implemented, but it's fairly common when you're talking about this sort of thing, is something that like full text search engines will deal with. So like things like Elasticsearch and Solr, and I've got a lot of experience in Elasticsearch, so it sort of popped up when I was thinking about this. Was that there's a algorithm called TF-IDF, which sort of, when given a particular document, it tries to find similarity to other documents in the corpus, and it deals with the fact that some terms are all over the place. Like some products, bag of bananas or you know, banana, is in every order, and so what it tries to do is it tries to sort of normalize for some of that, and that's something that I haven't investigated doing like in Anger yet, but it's sort of on the radar. And then I've got another option coming up. But yeah, that is a huge problem with like super popular items in anything like dense nodes and graphs. So I also at some point discovered that people usually aren't just buying one other product with plastic cups. It's like plastic cups and like Sauvignon Blanc, and there's usually not just 2 items in the cart. There's usually more. So like if you buy plastic cups and Sauvignon Blanc, what else are you gonna buy? And it comes up with more wine, which actually sort of makes sense. We have like plastic cups, and we have a white wine, and now we have a red wine. And then you have beer after that. So it seems like if you want to please everybody, get white wine first, then red wine, and then beer after that. So recommendations. Here is a sort of a list of things that come back when you try and find recommendations for chocolate sandwich cookies. And so the way I constructed this query is it finds all of the orders that contain chocolate sandwich cookies, and then it returns all the other products that were in those orders, just aggregated by the number of times they occurred. So in any order that contained chocolate sandwich cookies, there were 270 orders that had clementines also, and there were 233 that had pita chips also. And so this is kind of problematic, and this, to Mark's point, like there's this popularity problem, because if you cross out all the ones that are just like in the top 50 or top 70 most popular items, like you're crossing out quite a bunch of them, and 4 out of the top 5 are just what's popular. So you sort of have to look at some different approaches to getting better recommendations. And I can't remember when it was. It must have been early July that on this, I watched early July, the Neo4j online meetup had something about natural language processing. And one of the things that a speaker did is they talked about a word adjacency. And so essentially they have this corpus represented in Neo4j, where a particular document contains all these particular words in some order. And they talked about sort of figuring out what the likelihood of, or at least the counts of one word leading to another word, and then just counting the number of times that they had. And they sort of build another graph, like another dimension of the graph that sort of cuts across all of the words. And I figured that would kind of be interesting to do here. And one of the reasons that I thought this might help with the recommendation thing is because it takes proximity into account. So if a user ordered chocolate sandwich cookies, and then they order 6 more things, and then they order clementines, like that doesn't tell us maybe as much as if a user ordered chocolate sandwich cookies and then immediately ordered clementines, or ordered clementines just before they added chocolate sandwich cookies. So this idea of proximity you can start to play with and try and narrow down the results. And so this is the addition to the graph model. It's like all we have is like, we have all our products existing, and we're gonna add a next relationship between each product that occurs one after another. And then we're just gonna count the number of times that happens. And so this is the query to do it. And I kind of just ripped off the query that was shown in the word adjacency meetup, because it's essentially pretty much all the same thing. And this is, and so we're able to get and build out this additional dimension of the graph extremely easily without having to go back and change the initial definitions of what we're dealing with. And so while, when I mentioned before that we're evolving the graph model to add a vegetarian label, like that's a pretty small change. This is a little bit bigger of a change. But again, it's very easy to make. We don't need to really worry about the things that we've had modeled out. We don't need to adjust or like re-index things or anything like that. We can just add it in. So based on that, let's see what people buy after chocolate cookies. And we get a list of things that actually kind of make sense. So this is a product who has a next relationship to some other product, where the first product is chocolate sandwich cookies, and this is an aggregation of the second product. And we've got like Rice Krispies treats. That seems like probably the same aisle. Blueberries. Okay, I don't know about that. Soda, pistachios, raspberries, guacamole. So that's like sort of a form of avocado. So still making a show here. But I guess it all sorts of makes sense. These are kind of all snack foods, right? Blueberries are a healthier snack food than Rice Krispies treats. But everything that we have is sort of snacky in nature. And so for me, this is a lot more effective of a recommendation query than the one that we had before, where we had all these just really popular items. So this is just what people buy after chocolate cookies, but it doesn't matter if they really buy it before or after. It's like one step away, that's all we care about. So I've got these 2 queries here. The top one is the one that you just saw, which is what people buy after chocolate chip cookies, or chocolate cookies. And then the second one is what people buy before or after. And in the first query, I pointed out at the 2 things that I needed to change. The first thing I needed to change was take away the directionality of the relationship, which means that it'll match both directions. So it's very easy to sort of then check both before and after by just removing the caret. And then in the first time, we were just returning r.count because r was distinct. There's only one relationship leading from chocolate sandwich cookies to another distinct product. But now, since we're going both ways, we're going to have one going from chocolate sandwich cookies to Rice Krispies treats, and one going from Rice Krispies treats to chocolate sandwich cookies. And we want those both to sort of count and support each other. So instead of just returning the property count, we're going to sum both of those properties. And so in the second query, that's the only thing I had to change. And then we have something that's quite similar, except that you see there's a couple differences. Semi-sweet chocolate morsels didn't make an appearance the first time, but there's actually quite a lot of them here. Which is to say that I guess there's a lot of people who are buying chocolate chips, and then they go and buy chocolate sandwich cookies, like a non-trivial amount of times. So I don't know if that's just people are more like aspirationally like, oh, I'm going to make chocolate chip cookies, and then they're like, actually, I'm just going to buy cookies. You know, like that could be a thing. I don't know. We also see red plastic cups, soda, blueberries are still on here, guacamole is still on here. We still have a lot of the same things. But we are able to get it, like, you know, we're sort of in a sweet snacking mood, which I think is, you know, if somebody orders one of these items, it's probably legitimate to say, like, hey, you might want one of these other snacks. So what else can we do with this, this data? You know, we can try and figure out what people like to eat or drink when they're sick. So if like a person is ordering cough medicine or flu medicine or something like that, and they've got other items in their order, what are they ordering? Maybe that can give us sort of an idea of some different possible approaches to what people think they should be eating when they're not feeling well. Like, I assume chicken soup will be there, but there are probably a lot of unintuitive things also. And then on that note, like, can you figure out if people have unhealthy habits? Like, if you order flu medicine and a bottle of whiskey in the same order, like, they say on the label that you shouldn't be doing that. So maybe that's a way to sort of like identify these potentially harmful habits. And I mentioned this earlier, like, based on the volume or the frequency of certain items, can you figure out if you're ordering for a single person, a couple, or family? And then on the matchmaking side of things, my coworker Kevin brought this up, which was find somebody who's ordering a frozen meal, and then find somebody else who's ordering all the ingredients that are contained in that frozen meal, and then matchmake them. And the idea being is like, hey, you're going to eat the same thing, but one person is going to be eating the fresh version. So why not get together and eat the fresh version at the same time? And we don't have enough information in this data set to actually determine that. We would actually have to go through all the frozen and prepared meals and figure out what was in them, and have those point to particular other ingredients, like the raw ingredients. But we could, like, given that information, it would be very easy to add that information to the graph, and pretty easy to figure it out. We could also use that to, if somebody puts a frozen meal in their cart, we could recommend them, like, hey, you can do this, or you can make it yourself. Here are the 4 ingredients you would need, and here's a recipe. So there's definitely a way of, like, encouraging behavior based on what people are ordering. You can also do for matchmaking things like complementary ordering. So if somebody just put pasta and tomato sauce in their cart, and there's somebody else who just bought, you know, cups and a bottle of wine, like, maybe they should meet up together. And that seems like a pretty nice dinner. And normally this is where I would sort of open it up to the online community to see what, you know, if people have any other ideas. I don't know how quickly people can type, or does anybody have any ideas that you can share in the Slack or in the Hangouts?
Yeah, we'll have to give them a few seconds. I think it's about 20 or 30 seconds behind. We do have one observation, though, by user Sir Leb, I guess is how you pronounce that, so suggesting, going back to the highly popular items section, do you think you could consider highly popular items similar to how you would consider stop words in text, like the or a or an, etc.?
Yeah, and that's a good point, and that's one of the things that in the slide where I just kind of cross things out. Basically, doing that programmatically would definitely be an approach. So you would have to figure out where your, like, threshold is. Like, are you going to never recommend the 50 most popular items or 100 most popular items? Or do they have to be a certain level of popularity? Like if they've been ordered more than 30,000 times in this data set, or 300,000 times in this data set, like we're not going to even match them up. And but absolutely. And that would be the benefit of taking an approach like that is that it's a fairly straightforward approach that increases your relevance pretty rapidly.
Yeah, so we were playing around with the Meetup API dataset, and there you try and work out which, say, groups are similar to each other. And I guess the simple way of doing it is have a look at what topics or tags they have in common, and then you realize that everybody has the open source tag or some equally common tag. It's just like gives you so many results that are nothing like the one that you're currently on.
Yeah, and this is, I mean, that sort of approach, if you take it into like sort of a more dynamic approach, then you get onto this like sort of TF, IDF space where not only you're not necessarily just like statically removing these items and matching, but you're giving them a score. You're giving them sort of this relevance score, and then you can have it like cut off at a particular threshold, so you're only returning like the top results and things like that. Yeah, but if people come up with things, go ahead and throw it in the Slack. I found that in live presentations, this is the time when people like tend to have conversations, and I can just sort of step back. I know it's different online, but I think that a lot of other people who are tuned in will probably be interested in what you have to say. And so go ahead and write those things in the various forms of chat that we have. And if you get really excited about it, don't feel bad about not listening to the rest of the presentation. One thing to note, I will say, that, and this is one of the points that was brought up when I did this presentation in Chicago, was that all of these items, it's great for recommendations, but it's also great for building up sort of demographic information or lifestyle information about people. And one of the things that can be applied to is advertising. So if you think about all these, all these things that we're looking at, you can also apply that to way more targeted advertising. Like, so you can know that if you have a meat alternative product, you can, like with some degree of certainty, target a vegan. And it's, there might be some chance that they've never heard of this product or they never purchased it. But you can, offer this meat alternative and might be able to buy it. On Instacart, there's also the ability in a lot of regions to order from places like Target. And this data set doesn't really have any of that particular information. But based on what people are ordering at like a department store, you can figure out life events. Like, maybe they just moved or maybe they just went off to college, and like what they're buying, you can sort of determine life events. And then that's another way to target people. Mark?
No, you're good.
Okay, cool. Okay, so I'm gonna do this real fast. We only have 7 minutes left. In terms of production concerns for like sizing and import strategy, are going to be the two main things I'm going to talk about real quick.
Yeah, this is quite timely. Someone just asked a question about that, so I guess they're going to watch this next section.
Perfect. This is for you. And then again, so I'm going to go through this pretty quickly. Feel free to reach out in any of the various forms of communication we've talked about. I'm happy to help talk more about this stuff, and then we can also get like the Neo engineers on if you stump me. So hardware sizing, and then we'll talk about initial data load strategy. For hardware sizing, what you really want to pay attention is to memory. Neo4j tends to be more memory constrained than anything else because it's ideal that you will hold as much of the graph in memory as possible. Now, there are times when it's not likely that you'll actually be able to store all of the graph in memory. So if you're dealing with like large graphs, like you won't be able to necessarily max out the amount of memory that you have on a particular machine. But it's not terrible because like solid state drives are really fast, and the jump from solid state into memory is actually not that costly when it comes to to the overall, layers of costliness. It's like a pretty small jump to make. So there's I'll actually I'll throw it in the Neo4j online media. There's a great screencast on data sizing and things like that, and machine sizing for production hardware and whatnot. But the rough, real rough equation you can use is how big your data is on disk. This is how much memory you need is your data size on disk, and that's for your file system cache. Plus somewhere between 8 and 16 gigs of JVM heat. You can definitely give it more, but this is a good starting point. Plus 1 gigabyte for operating system stuff and just general computers need memory to run tasks off to the side. So that brings up a problem of well, how big is your data going to be on disk? And the way you sort of ballpark that is load a representative subset of the data and then extrapolate for the full data size. And so when I first loaded this in, locally I had just 34,000 orders, which is 1% of the data. So I loaded 34,000 orders, all the products, all the departments and aisles, and then so I could have fully fleshed out orders. I had 500,000 nodes, 1.5 million relationships, 1.2 million properties, and it was a third of the gig, so fairly small. So then, if you extrapolate that, your total nodes are going to be 41 million, total relationships 150 million, and then 33 gigs on disk, just by multiplying by 100. Now, with the based on that, you plug it in. We're looking at, you want 50 gigs of memory on a machine to run this particular data set. And that's not so bad. That's not an unreasonable amount of memory. You can do that with if you're on public cloud, if you're on Amazon, it's the M4 4XL. It's got 64 gigs of memory, so you got plenty of room to grow, and it's 80 cents an hour. So it's not going to break the bank either. Now, when I actually loaded the entire data set in, I was pretty close with nodes, and I was actually half the number of relationships I was expecting, and about the same with total properties, but the total size on disk was way less. And I was pretty stumped about this at first, but one of the things to note is that I didn't load a representative subset of my data because I loaded all of the products, all of the aisles, and all of the departments. And while in the grand scheme of things, those don't represent the most numerous items, but they all have name properties that are unique. And so when I presented this at the Graph Database Meetup in Chicago, one of the guys who was there talked about how it basically brought up this possibility that on indexing, those high cardinality items, take up a lot of space, and they kind of fudge the calculations. So that's something to keep in mind. You won't always be right. But the good side of this is that you can actually run this on an M4 XL or 2XL or something like that, and be running at maybe 16 cents or 20 cents an hour instead. So that's on the data sizing side. On importing a larger data set, I was looking at load CSV, and that's initially to play around with this 34,000 order subset. To load the entire data, I use Neo4j import. It handles larger data quickly. Load CSV, the whole thing takes me 20-25 minutes to load the entire data set. With Neo4j import, it skips Neo4j entirely. It goes from the source data, the CSV data, and then it just writes the bits on disk. And that takes about 3 minutes on my developer machine. So that's good. Neo4j import is deprecated. There's Neo4j admin import now, but it's not quite there yet. So they've marked Neo4j import as deprecated. They're working on getting feature parity with Neo4j admin import, but some of the CLI flags aren't available yet. So you're still fairly good using Neo4j import. I think the API is going to be pretty close, so there won't be any big concerns when updating that. This is sort of what it looks like. We've got the actual request that there's the CLI flag that pulls all the data in. And one thing that you do, or that I've done here, it's fairly typical is that the raw data CSV is no longer has headers, and then you can swap headers out as you need. For example, you can see, let's see, on the fourth line for the user nodes, I've got user headers attached to order CSV. And then a couple lines down on the order node, I've got order headers attached to order CSV. So we can use the same source data set with different headers to load the data in. And then I've got two examples of the header files down at the bottom, where we can specify like the node ID. So the first example is for a node. We're specifying which field should be used as a node ID. There's ways to ignore fields. I don't have any of them here. I'm pulling in all the data, but you can do that really easily with an annotation. And then there's also ways to cast data. So the order number gets cast to an int, the days since prior order gets cast to a float. So just for example. Then we have the last image here is for relationships. So we specify a start ID and end ID, and then if we want anything to come along for the ride as a property on the relationship, we can do the same thing we did on events. And I did this in 3 minutes. It imported 40.7 million nodes and all these things. And on disk, it's about 4 gigs on disk. And that is it. I guess happy to take questions, or Mark, if you have any have anything there.
We haven't got any more since the last time. I guess we're right near the hour, so maybe people have got to dash off. So so I guess I'll give people a few seconds to ask them. But thanks to Jonathan for presenting. And if you like the video, don't forget to like it on here. Oh yeah, so there were some people asking about the slides and the code. So you got that on there.
So here's the slides and the code, bit.ly/Instacart-Neo4j if you want it this moment. But if you can wait 5 minutes, I'll paste this into the online meetup and on meetup.com and the online meetup channel in the Neo4j Slack. So it'll be there pretty quickly.
Cool. And then online meetup next week, we don't have anyone presenting. In 2 weeks' time, we have Christoph Willemsen. We'll be talking about using Neo4j with Amazon's Alexa. So it's on the 28th of September. So yeah, you can register for that on the meetup page, and it will have the YouTube link on there. Otherwise, yeah, we got Alfredo saying great presentation, but I guess that's probably the last comment we're going to get.
All right.
Thanks everyone for joining, and thanks to Jonathan for taking the time to present to us.
Yeah, thank you for having me, and thank you everybody for spending some time with me.
Awesome. Bye everybody.
Bye.